Hi everyone, I hope you all are doing great. So today we are going to discuss about the new syllabus which has come for grade 9, chapter number 4, describing motion around us. And this is part 1 video where I will be discussing step by step all the questions which are end of unit, question number 1 to 10. Let's understand question number 1. My father went to a shop from home which is located at a distance of 250 meters on a straight road. On reaching there, he discovered that he forgot to carry a cloth bag. He came home to take it, went to the shop again, bought provisions and came back home. How much was the total distance covered by him and what was his displacement from home? Now, if you look at the question, students, you need to understand what exactly is happening in this. We need to jot it down what is given according to the question. So first let us understand that father going to the shop. So distance between the home and the shop which is mentioned, that is 250 meters. Now let's see what is the movement happening. Home to the shop, it is 250 meters. Then from shop to the home, it is again 250 meters. But if you read the question again, you will come across that he went to the shop again, he bought provisions and he came back home. So the distance which is traveled, now what is the question? How much was the total distance traveled by him? So the total distance traveled is 250 4 times, which is 250 plus 250 plus 250 and again 250 gives you 1000. So when you add all this, it gives you 1000. Now let's see what is the next part of the question. What was his displacement from home? Now students, you need to understand that what is displacement? It depends upon two positions. One is initial and the other is final. So he starts at home and he also ends at home, right? So what will be the displacement here? It will be 0 meter. Hope this question is clear. Let's understand question number 2. A student runs from a ground floor to the 4th floor of a school building to collect a book and then comes down to the classroom on the 2nd floor. If the height of each floor is 3 meters, find the total vertical distance traveled and the displacement from the starting point. Let's understand what exactly this question is all about. Now, student in the school building, what is the height mentioned there? It is 3 meters. If you can see it, I'll put a yellow here. It's 3 meters. Then, what is the movement again here? Ground floor and the 4th floor. So that is 4 into 3. So it is total is how much? 12 meters. Now from 4th floor to 2nd floor. Now here what you have to do is that 4 minus 2 into 3, that is 6 meters down. So you need to find the total vertical distance. So when you say vertical, this is the vertical distance and this is your horizontal. So what is the total distance now? It was 12 meters plus 6 meters, which gives us 18 meters. Now the second part of the question, that is displacement from the starting point. Now again, what is displacement? Final position minus initial position. So he starts at ground floor, right? 0 meters. And he ends at where? He ends at 2nd floor. So it is 2 into 3. So displacement will be how much here from the starting point? It is 6 meters upward. This you have to remember. Let's understand question number 3. A girl is riding her scooter and finds that its speedometer reading is constant. Is it possible for her scooter to be accelerating? And if so, how? Pause the video and think for a while what will be the answer. Let's discuss. Now, constant speedometer reading, think whether acceleration is possible. Yes, it is possible. A constant speedometer reading means a constant speed. But you need to remember that velocity depends on what? Speed plus direction. Student, please understand when we are talking about direction. Now, velocity, it's a vector quantity. So, speed is a scalar quantity. So, speed plus direction gives you velocity. Now, question is, a girl is riding a scooter and finds that the speedometer is constant. So, if the girl is changing the direction, for example, she is moving in a circular path or she is taking a turn, then speed is constant. Otherwise, when the speed is constant but the acceleration is changing. So velocity changes. So when the velocity changes, that means change in velocity. So there will be acceleration which occurs. So basically what is acceleration? Acceleration is rate of change of velocity upon time. So what is the conclusion? So conclusion is yes. The scooter can be accelerating if its direction is changing even when the speed is constant. Hope this point is clear. Let's understand question number 4. A car starts from rest and its velocity reaches 24 meters per second in 6 seconds. Find the average acceleration and the distance traveled in these 6 seconds. Now, first and very foremost important thing is that you have to write what is given. So what is given here? Initial velocity, that is denoted by small u, that is 0 meter per second. Now students, they mostly ask that how come initial velocity is 0? Please remember students that according to the question, if you see, a car starts from rest. So what will be the initial velocity? It will be 0 meter per second. What is the final velocity here? 24 meter per second. Time given 6 seconds. And what we have to calculate? We need to calculate the average acceleration. So what is the formula for acceleration? A is equal to V minus U upon T. That means final minus initial velocity divided by T. Substituting the values, 24 minus 0 upon 6 will give you 4 meter per second square. Now the next part of the question, and the distance traveled in these 6 seconds. Now you need to calculate the distance traveled. Now here you are supposed to use the equation of motion. So we have 3 equations of motion. Related to this question, we are going to use S is equal to ut plus half at square, because we are talking about u, that is initial velocity, we have the acceleration, we have the time given, and we have to calculate the distance. So now same, you just have to substitute the values and you're going to get the answer after calculation, that is S is equal to 2 into 36. So once you calculate, you will get an answer. Pause the video, substitute the values and see you will get the right answer. So likewise, we will understand the next question. Question number 5. A motorbike moving with initial velocity 28 meters per second and constant acceleration stops after traveling 98 meters. Find the acceleration of the motorbike and the time taken to come to a stop. So what is the first thing you have to remember? Write what is given. What is the initial velocity here? It is 28 meters per second, which is mentioned. What is the final velocity? Final velocity is 0 meter per second. Students, you have seen it in the previous question where initial velocity was 0 because the car started from rest. But in this particular question, it starts with, right, the initial velocity, that is 28 meter per second, but then it comes to stops after traveling 98 meter. It comes to halt, that means final velocity denoted by small v is 0 meter per second. What is the distance given? 98 meter. Now what you have to calculate? Acceleration. Pause the video, try to do the calculation. Let's discuss. So using this equation, now you might wonder that why we have to use this equation. Children, we need to find the acceleration and the time taken to come to stop. So you just have to substitute the value. V square is equal to u square plus 2as When you will substitute, you will get the acceleration as minus 4 meter per second square. So when you will calculate and transpose the value for A, you're going to get the answer minus 4. Now, second part of the question, time taken. Now here again, first equation of motion, V is equal to U plus AT. When you will substitute, you will get time taken, that is 7 seconds. Very important thing, please remember these three equations of motion. Pause the video, try to practice. These numericals are not difficult, it just requires a good amount of practice. Okay. Let's understand question number 6. Now, the figure shows a position time graph of two objects A and B that are moving along the parallel tracks in the same direction. Do objects A and B ever have an equal velocity? Justify your answer. Now look at this graph. It is a position time graph. Two objects A and B that are moving along. So you need to understand the graph. Children, the figure 4.27, this is the exact figure number which is given in your textbook. Now in position time graph, if you understand, the slope is equal to velocity. Please remember this. Now steeper the line, higher the velocity. So same slope, so it is equal velocity. Now if you have to understand in this, their slopes are different at all points. Now when we talk about slope, we even use the word gradient, and when you will study in maths, you will understand how to calculate y2 minus y1 upon x2 minus x1, which gives us in statistics or in the coordinate geometry, you will understand how to calculate slope. Now looking at this, if you find the two different lines, the slopes are also different. Let's take line number 8. Now it is a blue line which is steeper than line B, which is pink one. Just quickly mark this. So this is line A and this is line B. But both are straight lines. So what will happen here? Both have constant velocities. Please understand this. You can rewind it, you can pause the video and understand, because these graph questions are utterly important. So now question is, do they ever have an equal velocity? No. They do not have equal velocity since both graphs are straight lines and their velocities are constant. So the slopes of A and B are different throughout, even though the lines they intersect at one point or same position at one instant, but their slopes are still different at different time. No, objects A and B, they never have a equal velocity because their position time graphs have different slopes. So to conclude this, you need to understand that they will have a different slope. So when it is a different slope at different points, so they do not have equal velocity. Now looking at the question number 7, graph in figure 4.28 shows the change in position with time for two objects A and B moving in a straight line from 0 to 10 seconds. Now this is a position time graph, slope which is equal to velocity, total distance with actual path covered, which is considering the segments what you see here. Then average velocity, as we know, it is what? Displacement upon time, and average speed is total distance upon total time. So this is given. Now if you continue further and understand this, I'll quickly show the graph again. So if you look at the graph, you'll find that both A and B, they start from the same point 0 and 0, which is the origin. So it is starting from the same point. Both end at the same position at time, that is 10 seconds. If you see here the line and the dotted line as well. So what do we conclude here? That displacement is same. So A is a straight line. That is again understand from the previous question as well that it is a constant velocity. And if you see here B, it is a broken line. That means it changes direction, speed, and covers a long path. So what will be the answer? Finally, the correct option is that it will have same initial and final position. That means the same displacement and average velocity is same. Now understanding question number 8. A truck driver driving at the speed of 50 km per hour notices a road sign with a speed limit of 40 km per hour. Figure 4.29 for trucks. He slows down to 36 km per hour in 36 seconds. What was the distance traveled by him during this time? And you need to assume that acceleration to be constant while slowing down. So what is given? Initial speed, that is 54 km per hour, and you have to convert it into 15 meter per second. So converting kilometer per hour to meter per second, you can even multiply with 1000 divided by 60 into 60. So converting kilometer per hour to 15 meter per second. Then what is the final speed mentioned here? It is 36 km per hour, which is converted into meter per second. And when you calculate, you will get 10 meter per second. What is the time mentioned? It is 36 seconds. Now distance, when we calculate, students, you need to understand basically it is an average velocity. Now average velocity into time. Now how do we calculate average velocity? Initial velocity plus final velocity divided by 2 into time. So when you substitute the value, you're going to get the answer after the calculation, which is 450 meter. That is the distance traveled during this time. Hope that question was clear to you. Next is question number 9. A car starts from rest and accelerates uniformly to 20 meter per second in 5 seconds. If it then travels at 20 meter per second for 10 seconds and finally applies the brake to stop in 6 seconds, find the total distance traveled. Now here if you see, students, that 3 stages are mentioned. Okay, in stage 1, acceleration, if you understand, it starts from rest, as I told you and explained to you in the previous slides or the previous questions, that when anything which starts from rest, so we take initial velocity as 0. What is the final velocity? V, that is 20 meter per second, and time is 5 seconds. Now once again, if we have to calculate the distance here, so it is average velocity into time. So once you substitute the values, you get 20 upon 2 into 5. So distance, so the first stage, the distance will be 50 meter, because our main aim is to calculate the total distance traveled, which is in the question. Now, second, if you see, it then travels 20 meter per second for 10 seconds and finally applies the brake. So again here, what is the small v? That is final velocity. It is 20 meter per second. What is the time mentioned? 10 second. And then again, average velocity into time. So you will get stage 2, that is S2. Then you have stage 3, that is deceleration. Now again, for the deceleration, why it is mentioned? Because it has applied brake. So you need to understand, even if you use the word deceleration or use the word retardation, it is same. So what is u here? It is 20 meter per second. Final velocity is 0 because it stops, it applies the brake. Time is 6 seconds. So stage 3, when you calculate average velocity into time, you will get 60 meter. Students, here in the screen, if you will see in S2, it is 20 into 10, that is 200 meter. So this was kind of missing, so I'll quickly write this down. So it is 200 meter. It's 200 meter. So what is the total distance now? It is 50 plus 200 plus 60, which will give you 310 meter. So if you look at the question, please, it's a request, students, that read the question twice, write down what is given, and then see what you have to calculate. And then accordingly, you can substitute the values in the particular formula. Let's understand question number 10. A bus is traveling at 36 km per hour when the driver sees an obstacle 30 meters ahead. The driver takes 0.5 seconds to react before pressing the brake. Once the brake is applied, the velocity of the bus reduces with constant acceleration of 2.5 meters per second square. Remember, it's an acceleration, so the unit is meter per second square. Now the question is, will the bus be able to stop before reaching the obstacle? So first thing what you have to remember, what is given? Speed, that is 36 km per hour. You need to convert it into meter per second. Now here, what is the time mentioned? The driver takes 0.5 seconds to react. So you can even mention reaction time or only time, that is 0.5 seconds. And now here, okay, the other part stays that 0.5 seconds to react before pressing the brake. Once the brake is applied, so here what is the acceleration? That is basically a deceleration, which is 2.5 meter per second square. And what is the distance to obstacle? That is 30 meters. So you need to write down and jot down everything which is given in the numerical. Now let's understand distance during reaction time. So how, as we calculated in the previous slides, for distance it is velocity into time. So what is the velocity here, or the speed into time? That is 10 into 0.5. So we get distance as 5 meter, like how we calculated here. Then you have to use the equations of motion, which is v square is equal to u square plus 2as related to the values which is given in the question. So once you substitute the values, what is the distance you are getting here? 20 meter. So first S1 was 5 meter, and then the second S2 you calculate, that is 20 meter. So what is the total stopping distance here is? When you add it, you will get S1 plus S2, that is 5 plus 20, which is 25 meter. So will the bus be able to stop before reaching the obstacle? Yes, the bus will stop safely before the obstacle. I'm sure these 10 questions which were being discussed today was helpful to you. Request that you please practice it, and if you still have any doubts and you want it to be explained more in a detailed form or any areas, please write it in the comment section. And this chapter was describing motion around us, which is the new syllabus for 26-27. Questions 1 to 10, I've uploaded it step by step. Request that you please like, share and subscribe to support the channel. Now, next video, students, will be from questions 11 to 16, which is part 2 of the same chapter describing motion around us, right? So, thank you so much and God bless you all.